In this video, I'm going to teach you another trig rule called the sine rule, and it's another very useful set of equations or formulas that help you work out missing sides and missing angles inside triangles. And the great thing about it is that it can be used on any triangle, scalene, right angle, equilateral, isosceles, and all sorts, all those triangles. But if it's a right angle triangle, remember, stick to SOHCAHTOA because it's quicker. So the sine rule, I'm going to talk about it in a moment. It's a bit tricky to understand the first time round. If you really don't understand this, you need to kind of get in touch with me. I'll try and sort out some lessons, or I might get Mr. Hemming to do some Zoom lessons on it. But if you really don't understand this video at the end of it, then please get in touch with me or Mr. Hemming, and we'll try and sort something out, because it's an important rule that you need to understand. It's a bit tricky, and I'll sort of stay open to kind of like any questions you have at some point. Okay, now okay, just last week, remember last week we looked at SOHCAHTOA and cosine rule. Just remember the cosine rule again can be used on any triangle, and just remember how it works is there's two versions of it. One for working out sides, one for working out angles, and just remember the connections between the sides and the angles and so on. If you can't remember how to do it, rewatch the video because it kind of explains it in a bit more detail. But let's get into the sine rule. Okay, the sine rule. First of all, it can be used on any triangle. So it can be used on any triangle, but if it's a right angle triangle, stick to SOHCAHTOA because that's quicker. Now, the sine rule is a bit strange in how it works, and I'm going to demonstrate it in a moment. Okay, so let me explain to you what it is first of all. So, the sine rule is to do with the connection between an angle and its opposite side. So, a connection between an angle and its opposite side, and this is how it works. Let's say I know this angle here, or it doesn't matter if I know or not, but let's label that capital A. Okay, so angles tend to label them with capital letters. So let's call this angle A. And the opposite side to that, we'll label it little a. Okay, so first of all, in the sine rule, this is how you kind of label the sides. The angle is capital A, and then its opposite side is little a. Now, let's just label all the corners first of all, because that's important. If this is capital B, then this side opposite it would be little b, and if this is capital C, then the opposite side to it is little c. Okay, so that's how you label the triangles. So when you use the sine rule, capital A refers to an angle in a particular corner, any corner for that matter, but then its opposite side is labelled little a, and then B would be, and its opposite side B, little b, and C, and then its opposite side little c. That's how you kind of label it. Now, this is the sine rule. Now, this version of the sine rule that I'm going to write down is for working out missing angles. So let me write that down. So this is for missing angles, but we'll get to that later. Okay, so if I take any one of these angles here, if I work out sine of that angle, so this is why it's called a sine rule. Remember, sine is that button on the calculator, SIN, and if I just take sine of whatever that angle is, so if it's like, let's just pretend it's 30 degrees or something, or I don't know, 36 degrees. If I do sine of that angle, whatever it is, if I divide that, whatever that number comes to, so if I press sine of that angle and press enter, if I divide that by however big its opposite side is a, the sine rule says this: if I do that calculation, sine of that angle divided by its opposite side, then it's equal to sine of another angle, let's say B, divided by its opposite side. And in turn, that's equal to sine of the last angle divided by its opposite side. Now, it's written in three parts, but basically what it's saying to you is if you take any angle in any one of the corners, if you do sine of that angle and divide it by its opposite side, then that is equivalent to any other angle, so sine of that angle, let's say for example, divided by its opposite side. Or is equal to that angle, take the sine of it, so sine of that angle, whatever it is, divided by its opposite side. It will always give you the same number each time. Okay, now that's for missing angles. This version here is for missing angles, but we'll talk about that in a minute. But the thing about the sine rule is that it can be written in two different ways. So I can write the sine rule upside down. So what I mean by that is, if I take the following, so if I take a length, for example, let's say I take the length A and divide it by sine of the angle opposite the other way. So if I divide it by sine of the angle, then that's equal to any other length. So let's say B, for example, divided by sine of its opposite angle, and that's equal to the last side divided by sine of its opposite angle. So it's basically this upside down. Basically, if I flip each one of these fractions, the theorem still holds. Now this version here is for working out missing sides. So this one's for missing sides and this one's for missing angles. But basically the sine rule is just this. Basically, it's the connection, like I said, it's the connection between an angle and its opposite side. So if you do sine of an angle divided by its opposite side, then that's equivalent to sine of any one of the other angles divided by its opposite side. Or if you take a length of a side and divide it by sine of its opposite angle, then that's equivalent to another side divided by sine of its opposite angle. I'm going to demonstrate that now in another video, and then we'll look at, I'm going to demonstrate that now in another slide, and then we'll look at actually how to use the rule to work out missing sides, and then in the following video we'll look at missing angles. But don't close the video just yet because we're not finished. Okay, so here's a triangle where we know everything about it. We know all the angles in the corners, we know all the sides. I'm just going to demonstrate to you the sine rule here, and then we'll look at actually how to use it in a moment. So we've got both versions of the sine rule written down. We've got the ones where you've got the side on the top divided by sine of the angle, and then on the other one we've got the sine of the angle on the top and the sides on the bottom. Okay, so let's just do this top one here, and I'm going to ignore the kind of letters. I'm just going to explain to you that this here is a side, and this here is the angle opposite that side. Okay, so I'm just going to start off with any side here. I'm going to take 8. I'm going to divide that by sine of its opposite angle, which is 31.4. So 31.4. I'm just going to work that out on the calculator now. So I'm going to do 8 divided by sine of 31.4. Okay, so I'm going to use the fraction button. 8 divided by sine of 31.4, and just don't forget to put a little bracket around the sine 34 bit. Okay, so that comes to 15.3535. Let's leave it at 35. Okay, so that's what that bit there is. Okay, just that bit there. That doesn't represent anything at the moment. That's not the length or the angle of anything. That's just a number. Okay, so what I'm going to do now is I'm going to take another side and then divide it by sine of its opposite angle. So I'm just going to pick a side. Okay, I'm going to pick this one here. So I'm going to do 5.25 divided by sine of, okay, what's its opposite angle is 20. Okay, so let's work that out. So 5.25 divided by sine of 20. Okay, and lo and behold, it gives you 15.35 again. So it gives you the same number. So look, those two are equal to each other. Okay, they both give you the same number. Okay, and then I'm going to take the last side. Which is the last side? Okay, so it's 12, and divide it by sine of its opposite angle, which is 128.6. Okay, so let's do that. 12 divided by sine of 128.6. So remember, it's the side divided by sine of its opposite angle, so sine 128.6. Okay, and then look, it also gives you 15.35. They both give you, all three calculations give you the same number. That's what the sine rule says, that this will always be true. Now, I want you to do this yourself so that you get the same number. So type that in on the calculator and make sure you get the same number each time. Okay, that's what the sine rule says. Now that's just one version of it. I'm going to do it with the other way around. Okay, so I'm going to do this version now as well. So let me just delete all of this. Okay, so this version is a little bit different. Okay, so this version is just the upside down version of that. Okay, you've got to take sine of an angle and divide it by its opposite side. Okay, so let's do that first of all. Let's pick an angle first of all. Let's just pick a random one. Let's pick this top one here. Okay, if I do sine of that angle and then divide it by its opposite side, 12. Okay, it's going to give me a number, so let's work that out. So I'm going to use the fraction button. So sine 128.6. You should be doing this with me. Divided by 12. Okay, that gives you a decimal. 0.0651 roughly. I'm not writing down all this, I'm just writing down a couple of them. Okay, then what the sine rule says is if you do that again with another angle, so let's pick another angle, let's pick 20 this time. Okay, sine 20 divided by its opposite angle, so that's 5.25. Okay, then let's work that out. So sine 20, so please do this with me, 5.25 divided by 5.25. Okay, it gives you the same number. So look, that equals that. Okay, and let's just do it with the final angle. What was the final angle? This one here. So sine 31.4 divided by, so remember it's always sine of an angle, so sine of that angle divided by 8. Okay, so let's work that out. It should give us the same number. So does it do that? Whoops. Okay, so sine 31.4 divided by 8. Okay, look, it gives us the same decimal, it gives us the same number. So basically it's saying to you, if you take sine of any angle in the triangle divided by its opposite side, it's the same no matter which angle you take and divide by its opposite side. That's literally what the sine rule says. And these are the two versions of it. They're both the same, they're just kind of like upside down version of each other. Now, what we're going to do is look at actually how to use this to work out missing sides. Okay, so we're going to find a missing side now. We're going to use the sine rule to find a missing side, but we're going to use this version of it. Okay, so we're going to use this version of it, and I want you to write this down in your notes. Okay, so this is for working out missing sides, and you can see that all the sides are on the top. A, B, and C are the sides of the triangle. They're on the top. Sine of the angle, that's why there's this little degree symbol, because A represents an angle. They're on the bottom. So sides are on the top, angles, sine of the angle is on the bottom. Okay, now you never use all three of them, you only ever use two. So here's a triangle here. It's not drawn accurately, but that doesn't matter. We're going to work out this missing side P. Okay, now how do we use that? So we never use all three. We only ever use kind of like two of them, but I'm not going to bother using A, B, and C and all that. I'm just going to go straight into it. Now, if you really don't understand this, please email me and I'll try and sort something out if you really don't get this, okay? But I'm going to try and explain to you as simply as possible. So, I want to work out this side here. So what I'm going to do is I'm going to write that side first. Okay, so that's going to be like, I don't know, A, B, or C. I'm going to put the divide sign. Okay, so for example, that might be my side A. Okay, but I don't know it, so this might be my A. Now, on the bottom of that fraction, we need to write down sine of its opposite angle. So that's sine 32. Okay, so this is the side I want to know, and I'm going to divide it by sine of its opposite angle, which is 32. Now, I'm going to put an equal sign. Okay, like this. Now, I need to, on this side here, I need to do it again, but I need to know another side and another angle. Okay, so for example here, nice and conveniently, I've got this side here, which has got a length of 21. And by the way, I think these are centimeters. So 21. So I'm going to write that here, 21. That's how long that side is. Divided by sine of its opposite angle, which is 95. Now, we don't bother using the last one because can you see the third side hasn't got anything labelled on it. Look, there's no number here, there's no angle, so we're not going to bother using that one. And it doesn't matter about that third one, we'd never ever use it. We only ever do it with 2 of them because we don't need that third one. It's completely useless. Okay, but we just kind of write it in the equation just to emphasize that it will work. Okay, so let me reiterate what we've literally just done. Okay, so we've taken the side P and divided it by sine of its opposite angle. Now we don't know what P is, but we've written it anyway. So P divided by sine of its opposite angle, and then that equals the sine, this side here, 21, divided by sine of its opposite angle. And we haven't bothered using the third one at all, okay, because we never do. Now, okay, so look at this thing here. This is an equation. This thing here equals this thing here. So all we need to do is just some rearranging. Well, okay, just think about basic maths here. This side is being divided by sine of its opposite angle. So that there is just a number. Okay, so what's the opposite of dividing? Well, it's times. So P must equal this here, 21, divided by sine 95, whatever that is. Okay, whatever that is, times. So all I'm doing is literally multiplying this to the other side, so sine 32. So this is how long that side is. So all I've literally done, let me pick a different coloured pen, is I've multiplied both sides by sine 32. So that cancels that out effectively. So remember, like, the opposite of dividing is the times. So all we've done is multiplied sine 32 over. Now this is literally all I need to work out. So I'm just going to do that on the calculator. Okay, so what I'm going to do first of all is I'm going to work out 21 divided by sine 95. Okay, so 21 divided by sine 95. Please do this with me. Okay, that gives me 21.08 something something. And then I'm going to multiply that by sine 32. So times sine, by the way, you can do this in one go. Sine 32. Okay, so when I multiply it by sine 32, it tells me that P is equal to 11.17. Okay, that is how long that side is there. It's exactly 11.17. Okay, so we just used that version of the sine rule to work out that missing side. Now, I know it's written in 3 parts, but you never ever bother using the third part. You never use it, okay? Because the third side and the third angle are not known. The question doesn't even want you to work it out, so why bother using that? So just remember, it's that side divided by sine of its opposite angle. Right, we're just going to do it one more time, okay? Okay, so just bear with me, and I want you to do this with me. Or what you could do is pause the video right now and work out this side x, and then unpause the video and then watch it through and see if you get it right. Okay, so pause the video now. Okay, so this is the working out for it. Okay, so I want to work out this side x. Okay, so x, I'm going to write x, which is the length, divided by sine 29 equals, okay, so I need another length, so 30 divided by sine of its opposite side. Okay, so this is the equation, and then x is equal to 30 divided by sine 105 times sine 29. So literally multiply that over to the other side. Okay, so I've got to work all of this out. Okay, so I'm going to do that now. So I'm going to use the fraction button. 30 divided by sine 105. Multiply that by sine 29. And that gives us 15.057355. Okay, I'm going to round that to 1 dp. Let's say 15.1 to 1 decimal place, but that's what it says on the calculator. Okay, so I hope you got that right. Okay, so just remember, this version of the sine rule is a length divided by sine of its opposite side equals another length divided by sine of its opposite angle. Okay, I'm going to repeat that because I got that wrong, didn't I? Okay, so a length divided by sine of its opposite angle, and then another length divided by sine of its opposite angle, or some third length divided by sine of its opposite angle. But we never bother using the last one, we only ever use kind of like the first two. And really, I never bother using A, B, and C. I just kind of remember how this kind of formula works. It's dead simple when you get your head around it. Okay, what you should do right now is practice the My Maths task on finding sides and maybe have a go at some of the caboodle questions before you look at the next video. So don't view the next video just yet. Practice this version of the sine rule first before you look at the next video. Okay, thank you for watching, and again, if you get stuck, please email me. Don't suffer in silence. Sorry, I'll try and do something else, or try and get Mr. Hemming to do a Zoom lesson or something like that. Okay, so please kind of like email me if you're really not sure, because it is a bit tricky to understand. Again, I hope this video explains it to you. So what you should do right now is practice working out missing lengths using the sine rule, and then the next video is how to work out missing angles using the sine rule. Thank you for watching, guys.